So after doing that, what will be the final result is how many rows are there in the indices, that many iterations will be there and that many changes will happen. After this gets over, after accessing the two rows of indices, after incrementing the values, we have the final matrix. Okay. Now what we'll be doing, our next part of the question is return the number of odd values in the cells. Okay, means how many odd values are there in this cell. See here, this odd. Here also three values are odd. So total number of odd numbers are 6. Well, so we'll be returning 6 here. And here the total number of odd numbers are 0. So we'll be returning 0. How can we do that? We'll be accessing each element by using a double for loop, and we'll be checking if x percentage 2, x modulus 2 is equal to 0, means not equal to 0 means it's odd. If it's odd, do C++. And C will be 0 initially. How many odd numbers are encountered, that much time C++ will happen, and C will have the count of odd numbers which will be returning. Okay, so let's run the program and see. So here I am getting the correct answer. Okay, so let's move on to the next one. Our next question is matrix diagonal sum. Okay, so let's see what the question is. So in this question we have been given with a square matrix MAT. Return the sum of the matrix of the diagonals. Okay, so which is the diagonals in this matrix? 1, 5 and 9 and 3, 5 and 7, right? So what is the sum of 1, 5 and 9? 15, and the sum of 3, 5 and 7 is 10 plus 5, 15. This is also 15, right? So but 5 is repeated twice, right? Here also it is here also it is repeated, here also it is repeated. So only we will consider one time. So after getting the matrix, means the diagonal sum, will be subtracting with the middle element. So here I get 30 minus 5, which is 25. Okay. So one thing you can observe in the matrix is in the diagonal is this is the row number and the column number, right? This row numbers 0, 1, 2, and here also I have 0, 1 and 2. Okay. So in the this is the left diagonal, I guess. So in the left diagonal, the element means the row number and column number are same. In this element, for this element, the row number and column number are 0, 0. Here it is 1, 1. Here it is 2, 2. Right. In the same way, right diagonal will have, here it is 2, 0. So what is 2 plus 0? 2. Here I'll have 1, 1. What is 1 plus 1? 2. Here what I'll have? 2 plus 0? 2. Right. So whenever the sum I will get as 2, that is the right diagonal, and whenever the answers are same, means in this case means the row number and column number are same, those are the elements which are part of the left diagonal. Okay. So by using this concept, you can add the elements by using a double for loop. Okay. So let's try to write the code for it. First we'll have int I is equal to 0. Okay, and I will be running from 0 to mat dot length, I guess. Okay, so I have written a double for loop here for accessing the each. See, first I will be accessing from 0. I represents the row, J represents the column. Okay, so firstly 0, 0 will be accessed, then 0, 1, 0, 2. That means 0, 0, 0, 1, 0, 2. Then 1, 0, 1, 1, 1, 2. Then 2, 0, 2, 1, 2, 2. In that way we will access the elements, and only those elements we will choose, like if I equal to j. I equal to j means this location, right? Or we can have here I plus j equal to n. Means if I and j, that row number and column number sum is equal to the 2. Okay, in this case the length is 2. So if it is 2, that means a selected element. At that time what we will be doing is sum plus is equal to mat of ij. That means that element we are adding it inside the sum. Okay, so here we will have int sum is equal to 0. Okay, initially we'll have sum as 0 and we'll be adding the sum here. After this gets over, means these two loops get over, we have in the sum the total sum of the diagonals. Okay, and we have to subtract it with the middle element. Middle element means um, 0 1. 1 means how we can do is mat of n by 2, which will give 2 by 2, which is 1 comma n by 2. Okay, column number and row number is 1. Okay, after we subtract, then we have to return the sum. Okay, we'll return sum. Let's see if the code works. There was a slight change which I had to make, because when we access the array, right, see, I told you, right, like we have to cut this repeated element. That will be the case when we find out the sum of the diagonal in this way and in this way separately, and then we add. In that case, 5 will get added twice. But here what we are doing, here we are accessing each element, right? This element, then this element, then this one. In that way we are accessing each element once, right? So in this way 5 will get added only once. So we need not do the sum minus is equal to that one, the 5. Okay, so we need not do that. We can return sum here. One more thing, we have to do I plus j is equal to n minus 1. In this case n is 3, so 3 minus 1 is 2. So i's value and j's value, when it's equal to 2, the sum, at that time we will do sum plus is equal to the that cell value. Okay, so here it's 0, here it's 0 1 and 2. So 0 plus 2 is 2, and how we will get 2? 2 is n minus 1, n is 3, 3 minus 1 is 2. Okay, 3 will get by mat.length. That will return the size of the matrix as 3. Okay, so this is the code for the matrix diagonal, and let's move on to the next one.